Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM on financial mathematics. On January 1st, 2003, Mike took out a 30-year mortgage loan in the amount of $200,000 at an annual nominal interest rate of 6% compounded monthly. The loan was to be repaid by level end-of-month payments, with the first payment on January 31st, 2003. Mike repaid an extra $10,000 in addition to the regular monthly payments on each December 31st in the years 2003 through 2007. Determine the date on which Mike will have his last payment, which is a drop payment. Drop payment means payment of a different amount than the regular payment. What will happen here is that because he made 5 additional 10,000 payments, this will shorten the term of the loan because this will pay off the principal that would have been normally paid in the late payments, and of course this will reduce the principal balance, so his payments will have less interest and more principal from each time when he makes the additional payments. Note also that he made 5 additional payments in the years 2003 through 2007. Don't be confused that it's 4, because 2007 minus 2003 is 4. That's true, but that's not counting all points at which he makes the payments. And my way of thinking about why this is 5, not 4, is because a stick has 2 ends. So think about each year as a stick with 2 ends, and the whole period has the years are 3, 4, 5, 6, 7. That's 5 years. That's another way to look at it. Or simply think about this, that if the first payment was made in the year 2001 and the last in 2005, then you would clearly see that it's 5 payments, 1 through 5. Well, this is only shifted by 2 years to the right, so maybe I'm spending too much on this, but I don't want you to get confused about things like that. So here's the solution. The effective monthly interest rate is 6% divided by 12, because this is 6% nominal annual compounded monthly. So 6% divided by 12 is 0.5% per month. The equivalent effective annual interest rate is 1 plus this monthly rate to the 12th minus 1, and that's approximately 6.167781%. The monthly payment on Mike's mortgage is $200,000 divided by A angle 360.5%, and that's 1,199.10 approximately. Mike paid an extra $10,000 in addition to the regular monthly payment on each December 31 in the years 2003 through 2007, and the present value at time 0 of the 5 extra payments is, well, 10,000 A angle 5 at the annual effective interest rate, so it's 41,923.07 approximately. In other words, we can think about those 5 payments paying off this balance as of time 0. That reduces the balance of the loan that he is paying off. So the amount paid off by regular payments after these 5 extra payments. Of the initial 200,000, only 158,067.93 is left to be paid off by regular payments. And the regular payments are 199.10, and they pay off this balance, so 158,067.93 is equal to 1,199.10 times A angle N at 0.5%, and we need to find that N. If we use a financial calculator, I used BA2 Plus Pro to do this. If you enter 158,067.93 as the present value, negative 1199.10 as a payment, and you may wonder why negative, because the calculator assumes that you paying off a loan in the calculation, so the initial balance is has a different sign than the payments made against it. So negative 1199.10 as the payment, 0 as the future value, 0.5 as the interest rate. So remember, the calculator wants you to enter, say, 5% as just 5 and 0.5% as 0.5. And compute N. You give it as the job to the calculator. Then you'll obtain N equal to 215.7771537. Or you can just solve for N, because what we have here is that 158,667.93 divided by 1199.10 must be equal to A angle N at 0.5%, which is 1 minus V to the nth over I, right? That's the formula for A angle N that you must memorize. And that's equal to 1 minus 1.005 to the minus N over 0.005, so that we can solve this for N. The unknown is in the exponent, so you're going to end up taking the natural logarithm of both sides once you solve this equation for 1.005 to the minus N, whatever is on the other side, which will be 0.05 times the fraction that you see on the other side. And then you would end up 1 minus that whole expression equal to 1.005 to a negative N. And therefore N is equal to, after taking the natural logarithm of both sides, it will be equal to minus ln of 1 minus 158,067.83 times 0.5% divided by 1,199.10. This whole natural logarithm of it is divided by natural logarithm of 1.005, and with a minus sign from that minus N in there. And don't worry, the minus sign is just fine, because the natural logarithm in the numerator is a natural logarithm of a fraction. So this ends up being 215.776826. So a little bit different answer, but the same answer in terms of the question asked. This implies the drop payment at the end of 216 months. So 215 regular payments and then an extra payment. And that's 18 months exactly. So it would be the last payment in the 18th year. And 2003 is the first year, so 2020 is the 18th year, because if 2001 were the first year, then you would agree that 2018 is the 18th year, I hope. So this is just moved to the right by 2 years. Or a stick has 2 ends. So this is answer C. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.